There's an incredible need for donor organs in the United States. Most of the time, people talk about how long that waiting list and how hard it is to get an organ, but most people don't even make it onto the waiting list because the patients have to fit within a very narrow window of being sick enough to need an organ, but well enough to be able to tolerate the transplant. So if you want to work on permanent replacement organs, you need a multidisciplinary team. And it really depends on what approach you're applying. So at the Bioengineered Organs Initiative, we work on artificial organs, we work on tissue-based organs, and then we work on things that are somewhat in between the two. And so if you're going to work on artificial organs, you need people who have a great experience in the physical design of the device and a lot of experience with biomaterials, because in an artificial organ, the main problem with all of these devices is that artificial materials cause blood to clot when the blood contacts the material. And so what you need is someone with biomaterials experience as well who can work on materials approaches on the surfaces to slow that coagulation process down. And then you need people who are experienced in translating that organ and testing it for long periods of time and doing all of the research that needs to happen for that device to make it to the clinic. So if you're working on tissue-based organs, there are a wide variety of skills that you need to bring to the table, even more so than in artificial organs. So first of all, you need people who are experienced with tissue engineering. But tissue engineering on a totally different scale than what is frequently practiced. I think very often when people are working on tissue engineering, they're working on very small sections of tissue that are microscopic. So on top of that, you need people who are familiar with additive manufacturing, because that's what we're doing. We're making three-dimensional therapeutic organs on a large scale. And so we need people who are very experienced with repetitive processes for manufacturing. Other people in CMU may apply additive manufacturing to metals. Here in the Bioengineered Organs Initiative, we're applying that to soft tissues and organs. And then you need people who understand both the chemical needs of the cells in that organ and the mechanical needs of the cells in that organ. And so we need to make sure that all of the cells that we put into the organ have the right chemical environment, including the right nutrients and growth factors, and then also that they experience physical forces in a way that's similar to the native organ. I think then that the people who work on artificial organs are definitely needed for work on tissue-based organs as well, simply because they have the experience with trying to design something that may not look like the native organ, but still carries out the same functions. And then they have the experience of taking that thing that is not the same as the native organ and then doing long-term testing on that device and moving that towards the clinic. Because certainly, you know, we do not here at the Bioengineered Organs Initiative want to be a group that is doing this just in theory. We want to have permanent replacement organs that we are translating to the clinic. So the other thing that's unique about CMU is that we pride ourselves on collaboration, and that we have very low walls between departments. We're a fairly small university. We see each other all the time. We talk in the hallways about different ideas we have, and we all gather together to discuss engineered organs.